Factorising simple quadratics. So anything of the form ax squared plus bx plus c is called a quadratic. And that's whenever the highest power of x is squared. So if we had something that was ax cubed, that would be called a cubic. If it was ax to the power of 4, it's a quartic. But anything where it has a power of 2 as the highest power, that means it's a quadratic. What we're looking at today is factorising simple quadratics. So what we'll have is that it's ax squared, and it's going to be of the form 1x squared, so a is going to equal 1. If we think back to expanding out our double brackets, so we've talked a lot about the fact that expanding and factorising are opposites. So if you expand brackets, you get to form, and if you factorise that, you get back into the bracketed bit. Now, if we observe this expansion, what we can see is that the numbers in the two brackets are 2 and 3. And if we multiply 2 and 3 together, we get 6. And the other thing as well, if we add the two numbers together, so 2 and 3, we get the 5. Now, this is true for all quadratics of this form. So if we had x plus 5 and x minus 2, what we can look at is that the product of these two numbers, so 5 and minus 2, the product is minus 10. And the sum, so if we add 5 and negative 2, we get 3. So let's expand these brackets out and see whether those numbers appear. So using our FOIL, so we multiply the first together, then the outer, then the inner, and then the last. So x times x is x squared. Then we have a minus 2x plus 5x minus 10. And the minus 2 and the plus 5 are x squared plus 3x minus 10. And what we can see is that the product of minus 10 is the number term, as it was in the original one, and that the sum of 3 is the same as the sum in the previous example, which was 5. So this is a simple fact that's true for all quadratics of the form 1x squared. So if we can work out what the sum and the product are, and figure out two numbers that add to those, so if we had a sum of 10 and a product of 24, what we need to do is try and think of all the different combination of numbers that multiply together to give 24 and add to give 10. So hopefully we can all think that those are 6 and 4. So 6 plus 4 is 10, 6 times 4 is 24. So once we have that, those would actually be the two numbers in our bracket. So with simple factorising of quadratics of this form, the sum is the b, and the product is the number term at the end, which is our c. And that's relating back to the general format, where the sum is b, and it's the bx, and the product is c, and that's the number at the end. So let's look at these examples. So example A, factorise x squared plus 7x plus 12. So the sum is 7, so it's the number of x's that there are, and the product is the number term, so that's 12. So what we need to do is try and come up with numbers that multiply to 12 and add together to give 7. So if we work with the product, the numbers that multiply to 12 would be 1 times 12, 2 times 6, and 3 times 4. And the ones of those that add together to give 7 is 3 and 4. So our two numbers are 3 and 4. Now, those relate to the numbers in the brackets. So simply, we put in our two brackets, and the first term in each bracket is going to be x, and the number terms at the end are just our 3 and our 4. Example B, x squared plus 10x plus 25. what we've got is the sum, is the number of x's that we have, so that's 10. And the product is the number term at the end, so that's 25. We're looking for two numbers that add together to give 10 and multiply to 25. So if we look at the product, we've got 25 times 1, or we've 5 times 5. Those are the only ways to multiply to give 25. We notice that 5 and 5 work. So our two numbers are 5 and 5. That means our two brackets are going to be x is our first term, and then we've got plus 5 in each of the two brackets. We could check that and verify that it's right. So x multiplied by x is x squared. X multiplied by 5 is plus 5x. 5 times x is another 5x. And then 5 times 5 is 25. And that simplifies to x squared plus 10x plus 25, which is indeed what the question was. Example C, the sum. So it's the number of x's, and it's the number before the x. Now, there isn't really a number there, but whenever there isn't a number, that means that the number is actually 1. There's one of the x's there. The product then is the number term. And what it is, it's actually minus 12. So now we're looking at numbers that multiply to give minus 12. So we'd have 1 and minus 12, or you would have minus 1 and 12. 2 and minus 6, or minus 2 and 6. 3 and minus 4 and minus 3 and 4. So those are all the different combinations of multiplying to give minus 12. So the way that we'll get it so that they add together to give 1, so that's going to be minus 3 and 4. So whenever you add those together, you get positive 1. When you multiply them, you get minus 12. So we've got x in the first term of the first bracket and x in the first term of the second bracket. And then it's a minus 3 and a plus 4, because those are what our two numbers were, minus 3 and 4. Example D, we've got the sum is minus 9 and the product is 20, which is the number term. So if we think about all the numbers and multiply together to give 20, you'd have 1 and 20, 2 and 10, 4 and 5. But the way they are, they'll never get a sum of minus 9. So if we add 21, you get 21, 2 and 10 is 12, 4 and 5 is 9. Now we're close, we've got a sum of minus 9. So what we have is we haven't actually included all the things that multiply together to give 20. Because remember, two negatives multiply together to give a positive. So what we also can have is minus 1 and minus 20, minus 2 and minus 10, and minus 4 and minus 5. And now to get the sum of minus 9 and the product of 20, we use the last combination. So our two numbers are minus 4 and minus 5. So we've got our two brackets. This time it's a y squared, so the first term is going to be y. And then our number terms are the two numbers we just worked out, so it's minus 4 and minus 5. Example E, what we've got then is the sum is the number before the a, so that's minus 20. And the product is the number term, so that's 91. So the numbers that multiply together to give 91, you've got 1 and 91, 7 and 13, and they're the only ones. But again, what we have is that these first two are going to add together to give 92, and these will add together to give 20, but our sum is negative. So that's again where we need to think about the negative factors. So we've also got minus 1 and minus 91. So the two minuses multiply together to give a positive. And we've also got minus 7 and minus 13. And then it's this last combination that are going to add together to give minus 20. So our two numbers are minus 7 and minus 13. So we've got our two brackets. The first term in each bracket this time is an A. And then the numbers inside the bracket, we've got a -7 and a -13. Example F looks a little different. We've only got two terms here. So normally what we've had is we've had a squared term, an x term, and a number term. But here we can see that we don't actually have a number term. So we can actually write it in that way. So we could say that we've got an x squared, and we have no x's, and then we've got our -16. So these two expressions are exactly the same because I've added nothing to it. It just now is in a more familiar pattern. So now if we look at the sum, which is the number of x's that we have, it's 0, and the product is the number term. So that's -16. Then we look at all the combinations that multiply together to give 16. So you'd have 1 and -16, or -1 and 16. You'd have 2 and -8, or -2 and 8. Or you would have 4 and -4, or -4 and 4, which is the same thing. And out of those, the way we get to add together to give 0 is this last one. So 4 add -4 is the same as 4 take away 4, which is 0. So we've got our two brackets. The first term in each bracket, so we're dealing with x squared, so it's going to be x. And then one's going to be a +4 and one's going to be a -4.